Hey guys, good morning, buongiorno, bom dia, доброго ранку. Let me know if the sound and video is alright, and let's get started. It's been some time since I streamed, but then eventually I just want to stream again. So today I'm going to be trying to show you my process, basically, what I do when I create some kind of GIFs, some loops, stuff that I post on the Instagram or Twitter, things like that, like this. Some of them might look simple, but there's a lot of things involved while you create those. So I decided I'd show today one of these because I've been asked how to create this specific one with the numbers, which you might be able to see. I just hope everything is in place. Just let me know. It's just the start of the stream anyway. Hey, morning everyone. Let me know where you're from. It's always inspiring to see that people from so many different countries looking into the code that I'm writing live here. But let's get started. So this was the GIF that I tried to create at some point. This was inspired by actually Tatsuya bot. He didn't have okay, let me switch the screens. Yeah, it was inspired by Tetsuya bot. Tetsuya is actually a really awesome artist. I don't know how he can be productive as that. And so many motion graphics he's posting. And I really recommend following him. It's really inspirational stuff. He didn't have zoom though. He had kind of a similar idea with the numbers and spirals, but he didn't have a zoom and infinite kind of zoom. So I want to show you how you create this kind of thing with three.js and new TSL syntax. And well, here goes. Let's try to do this. Yes, this is it. All right. Greeting to Indonesia, Afghanistan, and Germany. Nice, and Romania as well. All right, so when I create GIFs, I usually use the SSAM model. SAM by the, okay, like this. All right, like this. By the Daing, and he was kind enough to update it with the WebGPU version. So I kind of love to create all the animations that I do with the WebGPU right now. This is the module itself. It might not be super popular yet, but this is my go-to module. This is a kind of inherited from the Canvas sketch by the Matt Deloria, and it's pretty awesome. So let's just go to the desktop, and I'm gonna do npm create latest version of this sum. I'm gonna call this text zoom. I'm gonna pick three.js here, web GPU. Animation, I don't remember if I need this animation in particular, but yeah. Hello to India and the Philippines. Wow. We've got that part of the world better represented than the European part, I guess. Yeah, okay. Installing all the depths. I think it's by default, it's not the latest version of the three.js here, so I actually like to do the latest. Is it the latest? Maybe 180 is the latest already? Anyway, so text zoom, let's go into the code. I'm gonna open up my cursor and npm run dev, and here we go. All right, I'm gonna arrange the windows somewhat like this. No. Like this. I guess I'd like to put the stream chat as well. Here we go. All right. So I'm gonna pop out the chat just so I'm able to see what you're writing while I'm coding. What like this? Yeah. Okay. Should be good. And this is the preview. And this is what you get by default here. Just some cube rotating around. And let's get started. So first of all, to create this GIF, I kind of need to create the, first of all, I need the numbers, obviously. I also need some kind of structure to put on these numbers. So I want to arrange the numbers so they fill the whole viewport, but then also they kind of zoom in and zoom out. So to do this, I'm going to try to use the squares first. I'm just going to try to arrange this all in a square. I also like to import and make it bigger. Import, no. So everything from the web GPU. I have all the modules. Now, what's in here in this template? Good morning to Lebanon as well. So what's in here actually? This is pretty simple. It's just 80 lines of code, and basically most of these are just the settings, predefined settings to render the stuff in here. So if I just press Command Shift S, I'm gonna record the video here with the WebM format, but I can also do it with MP4 format, do it 80 by 80, things like that. Actually, I can just go with a square canvas for now, so I don't overcomplicate things. And it fits kind of nicely here. All right. So there's also a render loop, a resize function, but the basic three.js stuff is actually just this. This is the whole thing. Not that much, just initiating the renderer, perspective camera, box geometry, material, stuff like that. This is a basic web GPU version of three.js material, kind of shaders, which we used before. This is it. So what we're gonna do with this? So I'm gonna just delete this whole thing, just leave the scene. So first of all, I wanna arrange some objects by the square border. So let's do the size. It's gonna be 0.1 because I'm gonna be using this a lot. And const get positions is going to be a square size, and the size is going to be not just the size in just width, but the size in the like how many squares do I have on each side of this square. This is going to be the side that I want. So I'm going to get these positions. I want this to be just an array, so let positions going to be array, and in the end I'm going to just return positions. For now, just trying to do something random for me, just probably the grid. And then let's just add to the grid. So the geometry is going to be plain geometry, just size. And I'm just gonna do, I just want to structure it in this way. So I'm gonna get the ring of objects. So let's get ring objects. And then I'm gonna use square size here. And then what I'm gonna do is I'm gonna let pos equals get positions, square size. I'm gonna create meshes here. This is what I wanna do. So objects, this is what the AI tries to help me. Probably what I need actually. So this get ring of objects will create just the meshes with my, I don't have any material though. So let material, just the green square. Okay, will do for now. And in here, the positions is actually, just make them nice, tidy vector 3 here. So for now, nothing is being added anywhere. I'm gonna remove this. So now I kind of want to see the grid of these objects. So 10, and then this is, let's make it a group. So let group, new 3 group, and on each, I'm gonna add the group. I'm gonna return this group. So this means these objects could be added now to this scene. Right. I was going to see something, but I guess this is problem with these arrays. So it's gonna be X, Y, and Z. No, not yet. Okay, now let's debug this. These are vector 3s. These have some numbers. This is too fast for you. Just let me get back for a second, because I kind of had this structure in my mind, so I wanted to create two things at the same spot. just 1 second, we're gonna see something and it's gonna be all easy because it's not the hard thing I'm trying to create now, mostly the structure of these functions. So these should get me positions of objects on a grid, basically just 10 by 10 or something like that. All right. So get ring of objects, and here we get positions with this square size. Get ring of objects 10 I'm getting, and I want to add these objects, this group of objects that I'm returning here in here. So I have the positions, object mesh. It's kind of disgusting that I stopped at this easy kind of moment. Get ring of objects, group. Okay. Let's see what's inside those objects. So the group has children actually. Maybe something with the like side, double side or something. This is why I don't see them. Position I and position length. Objects push group add object and return the group. Seems correct. And everything is being added to the scene, yet we don't really see anything. So okay, get positions. Let's just debug this thing. So let's my pos can be called get positions 10, and then my pos for each. It's like I'm not adding anything to the scene. Okay, scene adds new 3 mesh geometry material. Okay, this is being added now. I can see the objects, obviously. But these I don't see for some reason. So object position, copy. Why don't I see these objects? So dumb. Just adding them in a loop. If I don't add them in a loop, it just works. But if I add them in a loop, it doesn't. Object position, copy pose, and what the hell? Something really dumb happened. Okay, let's just add AI. Why I don't see these objects on a scene? Same position, but why same position? Oh guys, what is happening? Okay, let's just maybe try a loop. Just a simple loop from I to the 10, and that mesh is gonna be new mesh position x equals I something, and then yeah. Okay, this works. Some reason. Object position x plus x, and this doesn't. Okay, let's use AI. If you guys don't see any mistake that I made, it's probably, I don't know why. Okay, let the put AI to the usage for this dumb mistake. Well, this didn't help. This is something really, really dumb happening here. Okay, math random works. So It's probably the issue with my positions, right? This is the 100. Okay. Okay, this seems right. So this gotta be plus X. Maybe the positions are just too spread around, so this is why I don't see them. This is probably the reason. This is probably the reason. So here the X and Y are being multiplied, but it's probably too spread around. And this is the whole reason why we don't see objects. Everything is working as expected. It's just that sometimes some dumb mistake. Take some time. All right, so this is the position, and I'm gonna just, I don't even need this, you know? I didn't even need this grid at all. I just wanted to put it for the test purposes so we can see something. Yeah, I guess this was the reason this whole thing happened. All right, so now Y and Z, let's get them. Now we get the grids. It was just too big of a values, yeah. Ridiculous, just fucking ridiculous. We want to write some shaders, do some fancy stuff, and then we just put some value that's too big and we don't see anything, and you spend like 10 minutes fixing that. This is life. This is life of a developer, I guess. Yeah, okay, so we get kind of ring of objects, which is for now just the grid. And then I get this grid, and well, before I created this as a function that gets a grid, so let's get ring of objects. I don't have this function anymore, right? Oh, okay, I can have it in here. So I don't want to do this anymore. I'm gonna just run get ring of objects. At objects, get ring of objects, and then add this thing. It's gonna be same result basically because I'm transferring the same value 10. This is getting me some objects. So first function is just getting the positions for me, and second one is actually creating the meshes and doing the stuff to add this to the actual scene. So right now I want to switch this, and I want to create not the grid, but just the square, you know, like a circle, but a square. I don't know actually what's the best way to do just the square, but here's what I came up with. It's just kind of a dumb, straightforward way. So I'm kind of gonna go in with some directions. So let's initiate a vector. Gonna be a vector 2, 0, -1, let's say. So it's first gonna go to the left. We might change that later on. Then how many squares will I have? So the whole number will be square size -1 multiplied by 4. And this is because if I want a square with 10 on each side, it's basically 10 minus 1 multiplied by 4. How is, okay, squares on a square. Do we have some kind of thing? Like, there are actually images of what I'm looking for. Okay, anyway, even this image will do. So if I just want the squares on the edge, that means that I need 8 of them. Even though there's 9 of them, I don't need the center one. I just need the ones on the edge. And it's going to be 8. And 8 is exactly 3 minus 1 multiplied by 4. So it's 2, 2, 2, and 2. This is why. This is the whole number of the squares I will have on this square kind of border. And I also need the starting position of my square. And this will depend mainly on the size of the square and the number of the squares, right? Okay, the size of the square is going to be 0.1. I'm not gonna, okay, I have it here. And the start position is going to be, use vector 2 again. And what I care here is just, again, this corner grid positions for my squares. And this is going to be, I want to get the left bottom one. So it's going to be minus size multiplied and then the number of these things divided by 2, I guess. That's going to be the square size minus 1 and divided by 2. I'm just trying to get this position particular, the left bottom one position of a square here. And the second one is going to be kind of the same, I guess. Hello to Kiev. Доброго ранку. And so this is the left bottom position of my square grid. And then I want to have a loop, which is going to be looping for this whole number. And while I'm on a loop, on each step, I'm going to add to my start position. I'm going to add the direction. But direction might be changed. Direction clone. So I'm going to clone it. And I'm going to multiply it with my size. So because the direction is normalized vector here, 0. Not 0, just 1. And I'm should be walking in the steps of 0.1. Just going to multiply this with this. And I guess I'm just going to push the positions. Going to start position clone. And then I'll need to switch the direction. Because if I don't switch direction, I'm just going to get a line of objects. Just like this. But what I want, let's also change the camera, by the way, so we don't 0, 0, 1. So we look straight in the squares. And let's also add the wireframe here. And maybe the black background is gonna be better. Yeah, so we see this stretch of the squares. So now we're gonna change the direction when we get to the actual edge. So probably the initial direction is not correct. So I'm gonna go to the top first, or maybe to the, maybe I'll go this way, counterclockwise. And then in here, so if I equals 0, this is gonna be what I just put here, right? So dir is gonna be equal this. So then else if I can just do without else's even. If the I equals the square size minus 1, okay, this is basically the loop that I want to create. So it's first going to be 1, 0, then it's 0, 1, because we go into the top. XY means we're going to the top. Yeah, let's just see first 2, right? Then the next one should turn us to the left. Might not be the best way. That's probably a one-line code to do this kind of thing, right? But I don't know. I think it's also like this. Should be like this. Yeah. So AI wasn't that helpful here. Now we got the perfect square. Now, just for the debug, I want to see if my square is centered, because I have a feeling it's not centered. When I zoom into the center, kind of shifted. So I guess it's about the starting position, because I'm adding it on the first step. Maybe like this. No, not like this. And a cell size. Okay, maybe +1 here. Okay, almost centered, but not quite. -1. So where do we end up here? So it should be shifted. So it's centered vertically. It just should be shifted to the left a little bit, and that's it. Otherwise, it's fine. So just 1 point to the left. Thought that this should shift it exactly 1 point to the left. No? Oh, this is the y direction. Okay, so this is x direction. now perfectly synced. This is the science, actually. This is not just guessing the numbers. This is an actual science and how you code. All right, now we got the square. And with a little guessing, we came up with this. So now I want to put those rings, zoom them out. And I want to have the loop, say -5, 5. And I'm going to get these objects, not like this. So I'm going to get these objects in the loop, and I'm going to add them to my, let's call it a supergroup. So on each iteration, I'm going to get the objects. I'm going to not change the position, but I want to change the zoom for them. So I'm going to add them to the supergroup. And yeah, I'm going to add this supergroup to my scene. Okay, we've got something here. And I also want it also to be always 10, maybe always 7, let's say. So just the less squares on each side of my square, and looks kind of nicer. And then I want to also scale them. So objects, scale, set, color, and then what's going to be this color value here? So it's going to be some coefficient to the power of I, actually. So it's going to be, let's say, 1.5 to the power of I. This is what you get then. So you get this infinite kind of zoom structure. And if you get it between -10 and 10, I think 1.4 maybe better, yeah. So with 1.4 you get exactly, I guess you can derive this number from the 7 and 0.1, but this is what you get actually, an infinite tiled zoomed thing. Probably you get, if you get 10, it should be some other value, right? It's like 1.5, no, 1.2, 3, 25 probably, no? Yeah. So I guess this is the function of that number, but I kind of like how the 7 looks like. I think it's good. It's a good looking one. All right, so we got this. This is kind of closed in already, but now let's create the actual zoom effect with this one. How do you go about the zoom effect? There's the different ways. You could move the camera, but you could also scale the object itself. So in this case, I think it might be better to scale the object itself. Or maybe we should start with numbers. Yeah, let's actually start with numbers. So I'm gonna remove the mesh basic material. Let's create a node material. And material, color, node, function. Something weird. It's returning me here. I want to make them red. And I need to run this function right away. Color node. And it should work. Yeah. So now it's all red. And we get small black square where the zoom ends actually. Probably wouldn't be able to see it later on, but still, for now we see it. So we get the color node. Now, how did I create the font? Because we needed to create the font. And I actually spent also ridiculous time with this font, because once you find this time ticking font BB, something like that, ticking time bomb BB font family, yeah. And I found it, and I was so happy because I wanted to create this effect with numbers. Like you see here, there's a grayed out version of the number, like when it's not active, and you only see the active parts of the number. And I thought I could actually just draw this font into the canvas and create this version. I can draw the 8, because the 8 is basically all the lines active, and then I can draw all the active numbers on top of the 8. Well, little did I know that if you look closer into this time bomb font, especially in the numbers, let's just find the numbers for this font. I would show you how they fucked me up. So if you look closer, okay, maybe I can zoom this in. Yeah. So if you look closer in these numbers, like how the 8 and 7 corner is drawn, right? It's different. So I don't know what they were thinking when they drew this font, because this is ridiculous. And I was trying, and I didn't understand why it's not working, why it's just not perfect. Because even the 5 and 6 corner, you could see they are actually different. Whereas it's not the same thing that's happening on your like watches or all the other stuff where you see these numbers. Not on the ticking time bombs, actually. I guess on the ticking time bomb it actually works correctly, but not in this font. So what I went through with was actually to draw myself manually all the 8s on my canvas, and manually just highlighting the parts of those 8s into the numbers. So this is what I came up with. I had this small texture where I just drew all the 8s, and this is the 8 from this font, actually. Right from this font. But then I just filled in my Photoshop basically all the active parts of this font. So what is nice about this texture is actually it is equally uniformly divided into 10 squares. So these are all 10 squares for each number, and you could see it's like this. And then I could sample them depending on my actual needs. So let's just use this texture. 09 I call this, and this is my project, text zoom. We can do this with the Canvas 2D, and I think in one of the previous streams I actually did it with manually drawing the numbers into Canvas 2D, but this time I kind of want to use the texture. It's going to be looking much better. So numbers from what else? I call it 0.9 PNG rel. And then let's get this texture. Let's get this texture material color node here. I also need to set the sRGB, numbers, texture. Don't ever forget to set the color space, because the textures will look awful without it. And I also want to create the uniform progress. I'm gonna need it eventually. Uniform 0. And I guess I'll need to import that one. So uniform, what else do I need? Attribute, texture, mix, I don't know, maybe smooth step. Maybe like 3, maybe A10. Okay, I'm just going to import a lot of stuff, which I might need, because you'll need to import all the functions when you're using them in TSL shaders. So what do we have now? So we have the function that creates us a square. We have the function that creates us a ring of meshes. And all of those meshes are using the same material right now, this one. It's the material with the progress, uniform, and some color node just returns 0. So first thing, I want to actually sample to see some numbers. I want to see some numbers on my screen. And this is going to be, actually need to import UV as well. Kind of the most important thing that I forgot. So UUV is going to be UV, and then I'll need to fiddle with the shader a little bit to get this number right. So I'm going to multiply it with, on the X, I need to zoom it. And on the Y, it needs to stay the same. And that's also, it's got to be the vector 2 here. And this should already produce me something. Then let's output. Gonna be texture, numbers texture, new UV, and then out. Let's see. Vec2 is not defined. Okay. You always forget some. Right, getting there. So now we get all the 8s. Now if I just add something to my color node here, I'm gonna get the actual number here. So here I could add some stuff now. And depending on something, which we're gonna figure out a bit later, this could be any number. So to get the any number here, and because this is all two-dimensional stuff, I'm gonna add the two-dimensional thing here, and I'm gonna only need to move on the increments of 0.1 and only on the x-axis. So this way I'm gonna get 1, this way I'm gonna get 2. So I can do this with float, let's say, I don't know, 3, doesn't matter for now, and then multiply it by 0.1. Just so I can only change these numbers. Yeah, and I need to import float, of course. So this works in the same way exactly. I can put even 9 here. Right, all the numbers are working correctly. So this way I'm just mapping the texture atlas in TSL. This is how you do it. If you have something spread on the x-axis, you just multiply it with 0.1 basically, and then move in 0.1 increments to get every single texture that you want. And this is the same way that you create some sprites or stuff like that. What I like about this distribution of the numbers is that it's not particularly obvious that those are kind of squares at the first glance. I mean, obviously everything is rectangular here, but it's not easy to see the corners of these squares, like at least for me, I guess, because these twos here is kind of a bit more circular pattern for me or something like that. So it's not really that rectangular to my eye, because these numbers are kind of breaking the rectangular grid for me. So this is why I liked it, and particularly I guess the Tatsuya also liked this pattern because of that reason, because these numbers are kind of breaking the grid a little, so it becoming not that obvious. And where do we go from this? So now we need to calculate an actual number, like this float number between 0 and something, which we're going to put here. There's a bunch of ways to do this, and let's try to create something in the style of the bees and bombs. If you know the famous artist, the bees and bombs on the GIF, on the Twitter and Instagram, anywhere, the way that he creates spirals is actually by taking cosine function from the x and y coordinate of the mesh. But to get an x and y coordinate, I can't use position world here. I need to use some kind of attribute. And this is where I need to change my function that gets me the ring of objects. So this is the get ring of objects. And in here, the geometry, I guess I'm gonna be needing to create geometry each time a new geometry, right? Or just clone the geometry. Get ring of objects. Okay, it's gonna happen here. So let's go, it's gonna be geometry clone. Let's pos length, gonna be go attributes position count. Then I want to add the attribute to each of my to each of my small objects on my scene. So let port is going to be new float 32. Let's make it 3-dimensional. And in here, I'm going to put also the level. I want to get the level of my, like how much did we zoom actually. And this is going to be here, probably just the eye. And the last one is going to be the eye, because z is always 0 for all of them, so I don't really need them. So a coord is going to be new buffer attribute added to this geometry. So this means for each of these squares right now, I'm going to have the coordinate x and y coordinate, a perfect one. So far so good. We can actually even output it in my fragment shader here. So let's going to be attribute coord, and then I don't know, let's see, coord x. So the numbers that I have in my coord is actually quite big. Okay, obviously we don't have the division like that. And I guess this is not enough numbers here. Coord x. I wonder if I actually need to see anything in here, or it's just all correct already. So I'm getting this a coord, and I'm adding the attributes to my geometry, and I need to use the new geometry, Right. Okay. So now we see something. So just need to see that the attribute is actually working. So it says the y, this is the x. Okay, it's there at least. Now I can use. I have the a10 function, so now I can use the a10 function of this on this thing and calculate this. So let's first also calculate the distance from the center, and it's going to be length chord xy. Do I need to multiply it with something? I don't know. So let's also see this. Yeah, so this is kind of the distance, and because the distances are the same for each ring for now, this is not working properly because I zoomed them later on in my three.js function, right? But initially all the positions are actually the same. So this means that I need to multiply them with my zooming function. So it's going to be multiplied with 1.4, I mean with pow 1.4 to the chord z, I guess, because chord z is going to be the level of them. Pow is not defined. Okay. Yes, now it more looks like an actual distance to the center, which is what I need. And now we can proceed to actually setting up the spiral here. We have the distance from the center. And what I want now is to create the spiral. And the spiral is going to be, also need the remap function actually, which is does just map one coordinate to the other. So remap, not here, here. Okay, remap. I don't need the AI for this. So I'm going to remap. What I'm going to be remapping? So it's going to be a10 chord x chord y, or maybe chord y chord x. It's better, I guess, to start in the other spot. And this one is actually between like minus pi and pi. So I can immediately take the cosine function of this a10 function. So I'm gonna take cosine. So this puts this thing into the minus 1, 1. And now I can map the minus 1, 1 to 0, 1. So I can map the minus 1, 1 to 0, 1. And this should show something to me. Yeah. Now this is basically showing you what's the a10 function is doing. It's just calculating the angle from the center to each of those objects on the scene. So now I can actually add the distance to the equation, and this should create something for me. So I'm going to add the distance to the a10 function itself, I guess. So inside here, I'm just going to add d. And here we go with the spiral, right? I mean, it might not look perfect on the zoom in, but maybe multiply it with 5. Yeah. So now we could see the spiral because we are basically turning with the distance, we're turning a little this a10 function. So this is how you get spiral. And this is one of the best ways, I think, to create the visually appealing spirals. And once they are rotating, you just get, well, the rotating spiral. And now I can just multiplied by 5. In here, I can just sub the progress. And let's update the uniform progress. We're creating one of the GIFs from one of the posts that I posted recently. So the spiral is actually rotating now, but it's not rotating fully. This means that I need to multiply progress with 2 math pi. Right, so now we got the spiral. But now we have to somehow connect the spiral with an actual zooming function and make it a loop. But first of all, let's implement these numbers. Now that we have the spiral, we could actually create the integer number, which is going to be, like, let's say, floor of the spiral multiplied by 10, or 5, just so we have less numbers. So, and now with this number, with SP, I could put it in here, and we can get back to the actual numbers. And now we're going to get the spiral with numbers, which is actually looking pretty good already, right? So this is already kind of a nice GIF to create. We could have had a uniform grid here, which would do the same. I kind of like how the ones are on the edge, right? And then you're gonna, like, the greater the spiral, you get force in the center or something like that. If you get it to the even bigger amplitude, like 9 here, we're gonna get 8s and 9s here at some spots. I guess we should go with 10 to get 9s. Right, but this is a lot of numbers and starting to look a little random. So if we just had a uniform grid, we would be able to see like more numbers and more uniformly spread. This is the thing. All right, so I think in the initial I just used 4, just so we don't have a lot of numbers, just 0, 1, and 3. But I kind of like the freedom to play with this. Again, if you zoom out, the numbers are becoming so much big and it's hard to see the spiral actually. If you zoom in, the spiral is really detailed, but it's not even looking the spiral anymore. So you have to find the correct distance here so it zooms correctly. All right, so now about the zoom. This is what's left, right? The zoom and the depth of field. Let's do the final touches so we can create this. How do we zoom? I guess in this case, in most of the cases, I actually zoom with camera. So I just move the camera closer. But in this case, I find it easier to move an actual object. So the supergroup, I'm just going to zoom the supergroup. And the zoom is going to be exponential. So supergroup scale is going to be scale set color, and then what's going to be this color here? So it's going to be 1.4 multiplied with math. Oh, I think 1.4 to the playhead. No, okay, a group. So this way we kind of move in there, but I think the zoom is too slow, and to do the faster zoom, I'm just gonna square both of these parameters. Didn't quite work. Maybe -2 is gonna be better. Moving to in the other direction. No, okay. Maybe it's better to go this way then. So it's zoom out, but then okay, we go the other. So this is 7 divided by 5. I divide 5 by 7. Should probably do the same, but in the other way around. Right, I think this is better. So with this number, I can actually change the speed of my zoom, I think. Let's put 8 here. This is too big of a zoom, and I would need much more meshes to zoom out, right? I think 2 is kind of in the vibe of this animation, right? So we actually zoom in, but you could see that the animation is actually jumping in the end. And this is because, well, we zoom into spiral, and spiral looks different depending on this stuff. But we can mitigate that by adding the progress right into my distance. So in here, when I have the chord Z, which is the level, this level is actually slowly changing between 2 levels, right? Because we are zooming in 2 levels. And if you look closer, the GIF is actually zooms exactly 2 levels deep before it switches back to the original position. So this means that I could actually, in my material, I could add progress, and because it's 2 levels, multiplied by 2. So let's see if it's going to be the perfect now. Well, I don't see the seam now. It's now a perfect loop. And this is because we are moving exactly 2 levels, and I'm interpolating the distance also exactly in 2 levels while we are calculating the spiral. So this means basically the spiral is being calculated in the world position. And because I'm not moving camera, I'm just zooming in the object, the spiral always stays in the same spot. So this way, however close we zoom, if it's just an integer amount of loops, the spiral is going to look exactly the same. And we can actually try to see this, maybe just speeding this up. So you could see the size of the spiral shouldn't be changing. I mean, I should put the 8 in there now too, right? Because we are basically moving an 8. Now it looks pretty weird, but if you look at the center, like right here, it's actually not really changing. So it's the same numbers in there, but it's just too much blinking, right? Too slow for this animation. So I can bring back the 2 levels zoom. And it's all exponential. So if you just keep on making it to the power of some stuff, it's gonna just work for you. So then I think I also had the camera position. What's the camera position for me, which looked nice? So camera position, kind of an angle one. So I think I had the camera position something like 0.4 minus 0.2 and 0.6 or something. Yeah, kind of a nice angle to find because it looks more interesting if you zoom it in it this way. Now the last part that we need to add, and just a little bit of the post-processing. So it already looks pretty cool, right? No, it's not my template. It's a template by the Daink. Pretty good one, just SSAM. I described it in the start of the stream, so you can just maybe, once I post the video, you can look it up. So the last thing to add to this GIF to make it nicer is to add the post-processing. So I'm going to go three.js and examples, DOF, which is depth of field. But I want it for the WebGPU version. Which one should I take though? Yes, probably this one. So now I need to import some stuff, I guess, right? I need to import the depth of field itself and a lot of things like that. Where's the DOF? Doesn't seem like the existing depth of field module, so I guess I'm gonna take this one. Because I remember three.js has a, yeah, there's a three.js. Okay, let's import this missing stuff. So this comes from the three.js TSL. I don't need uniform actually. I have it already. The rest of the stuff is fine by me. Actually, which is nice, the three.js already has the lil GUI inside of it. I don't know, does it make any difference though, if you import it from the separate npm module or from the three.js? I guess better from the separate, because here it's going to be hard-coded version. But anyway, so now we have to initiate the post-processing. So I'm going to put the effects controller here. I'm going to also initiate the GUI so we can play with the depth of field a little bit here. So this is get train of objects, this is stuff. So in here, I'm going to initiate all the post-processing stuff that I need. Like a controller, just to put some rough numbers, I don't know, 4, and some small stuff here, gotta be. And also small number, some 0.4, I guess, something like that. And then I need to initiate the post-processing, and I need to initiate the GUI in here. So let's initiate the GUI right away so we see these numbers. I'm gonna also put them into some more plain ranges. 0.1, and this one is going to be between 0 and, I don't know, 3. Also 0.2 still even smaller, and this one, I don't know, a little bit bigger. So this is gonna get me the GUI right in my animation, which don't do anything because I'm not yet using post-processing. And let's initiate post-processing. Gonna be new 3 post. This is how you do it in WebGPU version. Post processing and just render, I think. Yeah. Where is that? Okay, here's post process, and then I need to get the scene pass, dov pass, and do the output function. So scene pass goes like this. Okay, let's change post processing to this so it works. Right, this should just work, I guess, for me. I don't remember if I need to multiply it with this small number. If I already put the real small number, I think it should be good to go without it. Aperture. Because here in three.js, they actually use the pretty big numbers for the aperture, but I already lowered them thousands of times anyway. So post-processing dov pass should actually do the job. Let's see. Now I need to switch the rendering to the post-processing rendering. So post-processing render. Okay, this works. It actually worked. And the Gaussian blur looks pretty cool. Now I can play with it. So I think like the max blur without any blur, this is maybe a little more of the range for this one, for the max blur. 0.6 at least, just 1. And in here I can do even smaller ranges maybe. Okay, the level of blur is actually quite okay with me. If I find the focus somewhere 2, then I can actually change the aperture just so it's focused in the center. Right now you could see the edge of the aperture, which controls how much of the depth of field you really get with this one. And if you hit it right, so it's smooth, but not too smooth, and then move focus a little bit further, I guess. Okay, it's just too big of a... maybe I'll make it, because I'm using really small numbers here, so I'm just gonna between 2 and 3, and 2 and 2, I guess. You can just do it like this, and the focus by default is 2. Okay, so now, yeah, it's much easier to control now. So now I can find the center of my animation. It's already looking kind of a cool look, right? So now if I just lower the max bloom, the max blur was 0.1 actually, and I just made it too small. Okay. I think the max blur was set as a too big one by default or something. Maybe do it like 1 something. Actually, some pretty cool effects that you come up with with this one by just blurring the stuff. Okay, and if I just change the max blur, it's pretty much should get me lightly blurred version, and then yeah, well, I guess this is it, right? We hit the number, so 2.8. I can put it here, 0087, 0087 in here, and 004 here, 004 here. Yeah, this is it. Of course, you can play with it for any artistic, no limits in here, but I think it was fine by me. It's kind of really close to the version that I took. Just less. our range so we can make more fine tuning here. Yeah, so this is it, guys. Pretty much, it's not that complicated maybe, but this is what basically behind all those GIFs that I create every day. Like I'm trying to create them at least every day, trying to push myself. This is what you do to create these loops. And just to highlight the most important parts is that if you want some infinite zoom stuff, this is always exponential stuff. So this is always something to the power of something. In this case, because we had the each new ring is greater than the one before by 7 divided by 5, I just raise all the animation scale to this power. And this way you're going to get the perfect loop and the perfect zoom with this one. And the speed is going to be like constant with this one. And it gets the illusion that the camera is actually zooming in here, but we know that this is actually the scale of this group. And it stays, the spiral is staying in the same spot because I'm using the world position, the world coordinate for this one. Now, there's a caveat in here because I could have used, instead of chord XY, I could have used position world here. Like, let's just try for a second, and so you see what's going to happen. Or position world here. It's kind of a cool looking stuff, but what is happening actually, because the position world is not tied to each of those squares with a number, but more to the like smooth position of the world, we're going to get different numbers on one square at the same time. So okay, max blur, remove it. So you see that we have same number, like two different numbers in the same circle, like, and they're switching by this circle of the distance of the position world, which is not looking particularly nice. So it's not, doesn't have this granular approach of each number just being on each square, because we have a couple of numbers on each square right now. So this is why position world doesn't work, and this is why we need to tie an exact coordinate to each square, so we'd be able to put a number in there. So this is going to be chord XY, and it's going to be all perfect now. Yeah, it's pretty cool. There's actually a spot in there with a black square, which jumps a little once the GIF ends. You could see that's adding 2 more levels, but you could basically change that by adding more of them, and then just not going to be able to see where it ends. And it's still 60 FPS, by the way, so it's not that big of a deal. It's 80 by 80 though, but it's still 60 FPS. We can make it a full screen, by the way. Just try to see whether we have the FPS drop if we have this blur for the full screen. We can enjoy the whole thing. I guess the focus needs to be a little changed here. Yeah, so the aperture is really what's doing the heavy lifting of this effect. I mean, the most important parameter at least. Yeah, we still have a... Okay, maybe the FPS drops here or no? Let's see, the FPS meter. No, it's still 60 FPS pretty much. This one shows 42 FPS for some reason. I don't know. Maybe it's something else. Anyway, this is what I wanted to tell you guys today. Hope you enjoyed this. And, well, let me know in the comments. It's always inspiring to see people, well, basically getting inspired by my GIFs or my streams and creating some more stuff. And I'd be happy to see one of your creations which were inspired by these ideas. And I hope to see you soon in the next streams. And if you have any questions, I'm gonna stick around for a minute in the chat. You can ask me anything or tell me something. But otherwise, I'm gonna wish you a great week, and I'm gonna wish you to don't ever forget to tell people that you actually love them, because life is fleeting. And it's also I'm so happy to see Makio here. So hello, Makio. You were really an inspiration for me in a lot of stuff. Because the stuff that you do and the creativity that you come up with is so awesome. Always so happy to see what you create in there. By the way, just a small announcement. While I was creating all this stuff, I actually found that I was missing the easings in TSL. So there's a GLSL easing module. I'm not really talking a lot about this module, so I'm just going to use this as a moment to tell you about it. So there's an easings for the GLSL, which basically ported from the JavaScript stuff to get the easing inside the shader. But I found that TSL was missing them, so I created my own version. I don't know, was I first? I don't know. Anyway, so I just ported all of those easings from the GLSL and JavaScript, and I ported them into the TSL syntax because they actually required a little bit of the fiddling. Because if you like look in those easings, this is how they look like right now, because they are in the TSL context now, so they will be able to be computed as a wglsl in the end. But yeah, anyway, maybe someone will find this useful, because I'm using them in my shaders in my TSL from time to time to create some effects. Not in this GIF, but still. I'm just gonna post the link. Okay, I was talking about something on the screen, and I'm just gonna post a link here. Yeah, I think I need to create more stuff in TSL, and obviously my courses about TSL are a long time overdue, so I'm gonna create a lot of stuff soon. I'm not gonna talk a lot about this because I'm better just do stuff than I'm gonna promise anything. It's been some hard times for me this summer, like both health issues, some stuff pleasant and non-pleasant happening, so but I'm getting there. We're gonna get there. And I'm really grateful for you guys like still watching me and keeping up with me, and thank you. Yeah, my screen is not visible. I'm just gonna show it one more time. Yeah, I know. So there was a like easings in GLSL, which I showed here, which look kind of like this GLSL syntax. And what I did, I recreated them in the TSL syntax, and now they look kind of TSL syntax, like SQRT, mul, sub, stuff like that. So these are basically just easings for the TSL context in three.js. So basically really narrow thing to do. So I wasn't sure anybody's using it, but well, 22 people found it useful, I guess. Anyway, yeah. So guys, thank you. I'm going to be ending this stream. And I thank you, and I particularly thank you for staying. Thank you to me sometimes, because it really means a lot. And this is the stuff that's moving me forward. So guys, have a great week, and see you in the next ones. Follow the announcements, and I'm hoping I'm going to be post a lot more in Twitter. At least some art, maybe not some useful stuff, but some art. Here goes. Have a great week, guys.